This video will begin to look at the topics from Chapter 5, which is still on cell biology. But now we will start to look at metabolism, as in energy and enzymes. So we'll look at some of these things here first, the role of an enzyme and the factors that influence the rate of enzyme activity. So with energy transformations and metabolism, cellular metabolism is the sum of all the chemical reactions of a cell. And catabolism, that refers to reactions that break down large molecules, uh, which are the products then in this particular instance, into smaller molecules, which would have been the reactants that make up the larger molecule, which would be the product. So a catabolic reaction then, um, this breaks down large molecules into smaller ones. An anabolic reaction or anabolism, that refers to reactions that make large molecules from smaller molecules. And you can see how they have it drawn out there for you with a diagram there. So with energy and reactions, free energy is the amount of energy that's available after a chemical reaction has occurred. So it's given by the equation. So the change in free energy of a reaction is given by delta G, and that equals the free energy of the products minus the free energy of the reactants. So if you get a negative number here, then that means that the products have less energy than reactants, and the reaction then will occur in the direction that's indicated. And so that means then that that energy is released in that type of a reaction if you get a negative result for delta G, and that would be an exergonic reaction. So that would be a reaction that's spontaneous and it releases energy. An endergonic reaction, on the other hand, this requires energy input. And so energy has to be derived from some source in order for these the endergonic type of reactions to take place. So many cell reactions they use the energy from exergonic reactions. So exergonic reactions, energy is released, and so therefore for an endergonic reaction to take place, it can take some of that energy and allow those endergonic reactions to occur. ATP then is essentially the energy currency of the cell, and ATP is made from ADP, which is adenosine diphosphate, and an inorganic phosphate. So what happens is energy is released when the bond on the terminal phosphate of the ATP is broken. So the terminal phosphate is released, and then energy is given off by that taking place. So this energy then is used for endergonic reactions in the cell. And they have a diagram there for you as well, which illustrates that quite nicely. So we have ATP, adenosine triphosphate. So you can see that the 3 phosphate groups are attached there. And so when one of the phosphate groups is separated, then energy is released from that. So that in itself actually is an exergonic reaction. So what you end up with is ADP, adenosine diphosphate, plus a free phosphate. And so the energy that is released by that particular reaction, that can be used by other reactions that require energy for them to take place. So that covers the topics from this first section here, and there's a couple of statements that are just referring to what we just looked at, and then here's the key terms once again and the concepts that we just looked at.